All right, so welcome to another session. And today we've got Tracy Fanara, who is an environmental engineer. She works now for NOAA. I've been wanting to talk to her for so long about, well, so much stuff. We talk a lot, Tracy, about everything from algae blooms to climate change to Marvel to everything in between. But today I wanted to chat to you about the Gulf Stream and particularly what it is, because I have a love for it and I have a fear of it. So I want to talk a little bit about it. So could you introduce us into what the Gulf Stream is, or what ocean currents are, what the Gulf Stream is?
Yeah, so ocean currents basically drive, it is driving our climate. I think so many times people think of the oceans as an effect of the climate, but it really does. It drives everything that we know to be true about where we live right now, about our typical climate schemes. And these ocean currents are the reason for that. They're driven by temperature differentials, pressure differentials, density changes, everything like that. And as it is right now, our world works in a certain way that is going to change with time. As temperatures increase, these temperature differentials will change. And when it comes to the Gulf Stream, a Gulf Stream, to me, in Florida, in the United States, the Gulf Stream starts with a loop current. So we have a loop current in the Gulf of Mexico, and this loop current is very important because we have a toxic species of algae in the Gulf of Mexico, and the initiation of those blooms is partly initiated by this Gulf loop current, depending on how high it is or low it is. So we have the Florida loop current. It goes up the Gulf of Mexico, down the west coast of Florida, and then up, meets with the Gulf Stream. The Gulf Stream goes up Florida, bringing all that warm water with it. And it's crazy how fast and strong that Gulf Stream is. If you go out and you're in the Gulf Stream, you feel it. And so many animals use the Gulf Stream for migration. It's really, our ocean currents are absolutely essential for a healthy, balanced ecosystem. So this warm water is actually brought all the way up to Iceland, England, and that's what's so amazing and shows that our world is so connected. And when I was little watching Mighty Ducks, there was a phrase that said, Iceland is very nice and Greenland is full of ice. And it didn't make sense to me then because I didn't understand how ocean currents worked. I didn't understand how that was possible when they're right next to each other. And the reason it is the Gulf Stream bringing warm water, keeping that area a wonderful temperature. So these ocean currents are absolutely essential for life as we know it. It brings precipitation when we expect it to. Like I was saying before, biologic populations that we depend on for food. So our ocean currents are extremely important.
And it seems to me, it's kind of a recent revelation that, 70% of our planet surface is covered in ocean. Lots of that, lots more volume to that. And we talk about climate change, really, it starts with the oceans, right?
Absolutely. And that's, my work with the National Oceanic and Atmospheric Administration. I took that job because of that reason. Our oceans is where everything starts. And I think that we get disconnected here on land from the importance of the ocean, from the importance of that balance of that ecosystem, the base of the ecosystem. It provides everything that we need to survive at the top. And in fact, when you realize that everything would be fine if we weren't here, but we wouldn't be if our oceans collapsed. And that's when you start to realize that we have a responsibility to minimize our impact and to preserve the health of our oceans.
I mean, for a good reason. We always talk about why should we do this? Why should we do that? Should we just be super altruistic and look after the environment and wildlife because it's the right thing to do, right? Should we just be completely selfless and just look after everything? You could be, but also it kind of everything, we depend on everything else. So we have to look after it because we need it.
You're exactly right. And a lot of people are thinking, oh, well, that's, generations down the line, they'll be impacted. Well, first of all, it's not true because we're being impacted now. And it's not just, it's not just these impacts, right now we're in the sixth mass extinction and most of us aren't really feeling that yet because a lot of microbes far outnumber us in species and number. So we're not feeling it yet, but it's kind of like dominoes. Jenga. You start taking out the pieces and eventually the top collapses. We absolutely depend on all these species. It's kind of like a game of Jenga. Once you start taking the bottoms out, eventually the top will fall, but it's not just future generations. First of all, we are seeing these changes now and very shortly they're going to start impacting our quality of life. We're already seeing that in some places with the prevalence and intensity of toxic algae blooms increasing, cyanobacteria blooms. We're seeing it with sea level rise. We're seeing it with saltwater encroachment. We're seeing it all over the world already. But soon enough, our quality of life is going to decrease for more people. The cost of getting clean water is going to increase. The cost of homeowners insurance, the cost of bringing in fill to keep our coastal communities up and stable is going to increase. So very soon, if not already, we're going to be seeing the economic cost of climate change. And that's where, no matter where you stand on the political spectrum, it doesn't matter. That's where we come together. The science isn't just cute and cuddly, let's hug some trees and protect some animals. No, we're protecting our wallets, we're protecting our health, and we're protecting our quality of life. And that's really what we have to focus on, because if we do that, we can build a bigger team, and no one can save the world alone. We got to do it as a community.
And I think something that affects, on these global scales, ocean currents, air currents, America just had a massive change in the air currents up there, which happens, again, it's these things that, big ocean currents and big air currents, they change all the time and everything is connected. But what we're starting to see is that things like the Gulf Stream, which is changing, would normally change in a kind of predictable way and in a longer lasting way. But we're seeing these weird events now.
Yeah, a lot of these anomalies and extreme events are related to climate change, and it is a little confusing until you actually look back on the science. Like what happened in Texas. Yeah, we've had the polar vortex drop, and we've had these anomaly, really cold periods, but never has it gotten as south as Texas. And while that polar vortex is coming down, then we have warmer waters in the Gulf of Mexico. That temperature differential sparked a series of deadly tornadoes in the past week. So it really is all connected. And as far as the Gulf Stream goes, with warming waters, less of a temperature differential means less of a driver for water to move. And the reason why we're worried about that is not only climatic changes with precipitation in places that depend on it, but what we're most concerned about is the ecology of it. People that depend on fish or seafood to survive. Those are the people that are going to feel those impacts most. And that's a problem. Fishing, fish farming, commercial fishing, that is a worldwide issue that we really need to focus on in order to preserve what we can from the changes that our ocean is going to start experiencing or already is. I could go on all day about that.
Yeah, and it's because it's so important that science is one of those things where you start to unpick it and you end up with more questions than you had in the first place, which is why I love
science.
New studies. And it's like, oh, we answered this thing. Well, actually, we got 10 more questions.
At the end of every single publication you will ever read, more research must be done.
Yes, of course. So when looking at, we talk about everything's interconnected. Like, I wanted to concentrate on the Gulf Stream for this one because it's one of the largest ocean currents. And it's one of the closest to home, literally for me. I live
And me
in Wales, in the UK, and you as well, and a lot
in
of people.
Florida.
So
It connects us. There's our connection.
it really does, but it also connects because they start in Africa with the trade winds, and then
Right.
comes across.
Right. And then comes across and yep.
So it literally connects all of us. But one of the things that I'm always blown away by is how temperate the climate is here in this part of Europe, and the fact that it's just, I feel like it's artificial, that it's not actually real, because we're on similar latitudes to like Canada and Siberia and these really cold places. So the Gulf Stream, big ocean current that moves up the coast of North America, across the Atlantic, into the North Atlantic, and then gives us all this warm water.
Right. From Florida.
From Florida. Thank you very much, Florida, for all your warm water.
You're welcome.
But 300 million kilowatt hours of energy is delivered from this big current, and gives us our temperate climate. So how does that change then weather systems, the air patterns that go along with it?
Yeah, and that's a good question. Right now, it's not. Most scientists are not predicting that the Gulf Stream is going to stop entirely. They're predicting that it might slow down, which is understandable, knowing that even the large amount of zooplankton that diurnally travels up and down the water column is slowing the Gulf Stream twice daily. Of course, temperature, the lack of temperature differential as it is right now, is going to impact that. But so what happens is less warm water will be evaporating and causing precipitation. However, we do have warming oceans. So the question is, will the ocean on its own increase temperature enough to combat the slowing of the Gulf Stream? And that I don't know. And I don't know if, this whole weakening of the Gulf Stream, it's still controversial. It's new data, but that information is being supported. Every time I turn around, there's a new publication supporting the weakening of the Gulf Stream. So this is a very real possibility. And then with the lack of precipitation, I mean, you guys depend on snow. I mean, not only just snow for skiing, but hydraulic water cycles are dependent on the freezing and thawing system cycles that they go through. I mean, so many places are dependent on their water from the melting of snow. And we're seeing that in many places right now, that because they're not getting the amount of snowfall that they used to, they're having droughts. So that's really, I mean, what do you think? What do you think is going to be the biggest change?
Well, I mean, we've also got to mix into all that, because it is the thermohaline circulation, meaning that you've got thermo, you've got the warm water, the haline as well, the salt. As Greenland starts to melt, that's going to add a whole different
that's right,
literal mix into it.
Right. So
it's something that does scare me on a daily basis. But you're right that delivery of warm energy to the northern part of Europe, Iceland, even to extent up towards Greenland, it is what we've built our society around here in Europe. And like you said, that warm water, when it evaporates, it heads up into the sky, it creates clouds, and then that clouds come down, if it's cold enough, as snow. That builds water towers, glaciers, and ice caps that thaw in the summer. It delivers water to everyone downstream. There's a big chunk of Europe that just depends on those water towers.
Exactly.
And over time, they are going away. So, we started this talk saying that everything is connected, like everything's connected. And a snowflake falling in the Alps is connected to the trade winds that come off of the coast of Africa.
It's amazing.
Kind of insane.
It really is. I mean, the trade winds from Africa are that's actually my favorite example of how everything is connected. And up to this point, I would stop at Florida red tide, because that's what I worked on and what I focused on due to the Florida water crisis in 2018 when we had 2 toxic algae blooms. But the Saharan dust coming over to the Gulf of Mexico and to the Amazon. So it's feeding the Amazon, which is great, but it's also feeding this toxic species of Florida red tide, a micronutrient iron that it's limiting to this species and allowing it to proliferate and bloom. And that toxin causes mass wildlife fatalities, public health threats, closures of recreation, completely took down economics of Florida in 2018. So it's crazy to see how, and then with climate change and with changes of surface water quality, all of this runoff that we are lowering the water quality. So we have lots of nutrients coming into our coastal waters that are then, of course, feeding the bloom, along with increase of population, wastewater overflows, and it's crazy to think, because you think that that's a local problem, right? But it's influenced by sometimes hurricane events that start in the Atlantic by Africa. Sometimes it's the Saharan dust. It might be 40% of the U.S. that drains to one area, bringing nutrients, and it's the second largest hypoxic zone in the world. There's so many different things, and then to think that that's where it stops. You think living in Florida, that's where it stops, but it doesn't. Because, so far 9 times that toxic bloom was brought up by the Gulf Stream up the East Coast. So we really are all connected. And when I think about the Gulf Stream, for me, the scariest part is the tuna run. The tuna that the ecosystems in Florida depend on, or the East Coast of the United States, I should say, that come over from all of these ocean currents that are now weakening, and they don't have the energy, the capacity to make that trek without these currents. So what's going to happen to that population that's so important for ecosystem balance?
Yeah, and I can't help. I do get a little bit of eco anxiety when diving into these kind of things now. And I think that's normal for people to have. Like, there's a lot of bad stuff out there at the moment in terms of the news that we're getting. And I think the important thing to know is that what can an average person do to affect climate change and the halting of climate change, the slowing down of the effects of climate change? Is this something that we can do as individual people? Is
Absolutely.
that something that we take on as a bigger level?
I mean, we power in numbers, right? But the thing is, like, it starts with one, and you are the only thing that you are 100% responsible for is your own actions. And like I'm doing this piece right now on Nestle and their bottled water, and taking it from the watershed, my watershed, and then selling it all over the world, creating all this plastic trash. But I can't point the finger at Nestle because there's a market for it. That's capitalism. I can't point the finger at Jenny Springs where they're taking the water because that's business. You can't combat greed. It's everywhere. But what I can do is not buy bottled water. I can make a change in the market. I mean, and that goes with oil and gas, that goes with reducing your energy costs, finding alternative energies, solar panels, whatever it is, and it does pay off in the long term. Changing the market is 100, and in education, we don't realize all the things that use fossil fuels. We don't even realize it. I mean, and we need even a bigger change at the electricity level, because you think, I have a Tesla. plug in the Tesla, and even though life cycle analysis says that it's more environmentally friendly, if my power plant, and even if the power plant is getting from oil or gas or coal, it's still environmentally friendly because it's efficient. But at the same time, if we're not changing those sources, then we're not doing as well as we could do. And I mean, and then that goes back to creating programs that allow the transition from oil, gas, and coal to renewable energy. And that's going to take paid training programs. That's going to take, increased skills in those workers. There has to be incentives, because we can't just say, we're not doing that anymore. You guys are on your own. Go work at Target. That's just not going to be a socially acceptable solution, because we already have so much division. That would just create more. Now we need to start bringing people together and giving people better opportunities than what they have right now to go to alternative energy is what we need to be focusing on.
I think you hit the nail on the head when you talk about education. Like, I think that we are turning the tide, so to speak, excuse the pun, on how many people talk about climate change and how many people know about it and the effects that we're having. And, the people that will be watching this all play in environments that are going to be greatly affected. I feel like alpine environments, Arctic environments, oceans, they're all like at the forefront of where the change is going to come first. And so we all have a responsibility to not only learn it ourselves, but also talk to others about what we've learned.
Right. Absolutely. Absolutely.
Well, Tracy, I could talk to you, and I probably will, all day about this kind of stuff. But for now, Tracy, thank you so much for coming on and speaking to us about everything Gulfstream.
Thank you for having me.